Hi, my name's Melissa Klein.
And my name's Katie Wolgast. When you see these cars, you might think that they're just toys and something to play with, but in this video we're going to show you how you can use manipulatives to solve math problems.
So to start off our presentation, we are starting off with a problem for our peers. So what we did was we went around to some of our peers at Wichita State and asked them how they would solve this problem. So the problem was, Derek wants to be a pig farmer. He is building a pen and each pig requires 4 square feet of room. If the pen he is making is 5 yards by 20 feet, how many pigs can he have? So after allowing them to see the problem and reading it to them, we asked them to solve it however way they wanted to. So we found 2 common ways that people solved it. The first one was by just simply stating the information that he knew. So he started off with, he knew that 4 square feet was how much each pig needed, and then he stated that 5 yards times 20 feet was the total amount of space for the pin, and then he started converting. So 1 yard is 3 feet, multiplying, and then he just went down and worked his way all the way down with multiplying, dividing, and came to the conclusion of 75 pigs. So then our second way, they were a little more visual with the way that they stated the facts that they discovered from the problem. So she drew a box of the pin, and she converted 5 times 3 is 15 feet, so she wrote 15 feet by 20 feet equals 300 square feet. And then she solved it the same way of using multiplication, and then she divided and it came to the same answer. So really, it was awesome to see that they worked the same way but visualized it differently.
So the next way that we wanted to demonstrate this mathematical principle is by doing a problem for K through 6. So in this problem, basically we have a teacher who wants to take her students on a field trip, and she has 16 people that she's trying to transport to the zoo, and each car holds 6 people. So basically the students need to figure out how many cars the teacher will need. So we identified 4 different ways that students can solve this problem. The first is by using the standard algorithm, which we have over here. So the students know that they need to transport 16 people, and they basically need to divide these 16 people into groups of 6. So they write their 6 here, and then they are 16, which is the number they're dividing it into there. So they see that 6 goes into 16 twice. They write their 2 up there. 2 times 6 is 12, and then they subtract, and they realize that they get a remainder 4. So their answer is 2 remainder 4. Some students will write this as a remainder, some will write it as a decimal or a fraction, but basically they're using the same method. And then our next way that students could do it is by using the circle method. So they draw 16 different dots to represent the 16 people that they have, and then they put these 16 people into 6 different cars. So they circle them by groups of 6. So here they see that they have 2 full groups of 6, and then they'll need a 3rd car for the remaining 4 people. The next method that students could use is called the box method. So they have their 6 on the outside, and then they realize that they're dividing that into 16. So they have a tens box and a ones box. So they see how many times 6 will go into 16, which is twice. So they write that 2 up here, and then they do 2 times 6, which is 12. So they subtract 16 from 12, so they have 4 ones left. Then with those 4 ones, they move that into the ones box, and they say how many times will 6 go into 4? The answer is 0, so they know that they have a remainder of 4. And then lastly, another way that a student can think about this is just by kind of skip counting and thinking about it logically. So they know that they have, they need to get to 16 somehow. So they say, well, if I have 1 car, that'll be 6 people. If I have 2 cars, that'll be 12 people, which is close but not quite. So we're going to need 3 cars, and that will give us some leftover space.
So congratulations, you just worked through 2 problems that we kind of explained in the mathematical practice 2 of helping students to be able to reason abstractly and quantitatively. So pretty much what that standard means is, it sounds confusing, but it's very simple. So really it's just helping students to decontextualize the problem, and so breaking it down. So like understanding, what is this problem even asking me? Like, what am I supposed to answer? And then figuring out what data do I already have so that I can solve this problem, and then what method is going to work best for this problem. And then being able to contextualize everything, and so they're working through that problem and then figuring out, okay, so I got this number, now what does this mean? How is this going to answer the question that was asking the problem. And so they have to like look at their units, like maybe they need to convert it, or it's like dealing with people, so you can't have a person, so they need to round it up. So whatever it is, it's helping them to realize that that they have to apply this to their life. And so that's why it's very important to teach students in like word problems, because they can use these different methods. They have to kind of think through and think like, how is this going to make sense? How does this apply to my life? And you can use that. You can use like number lines. There's a lot of different methods that Katie's going to talk about next, but manipulatives are great so that they can visualize these things when they're first starting out. And so I'll kind of let her tell you about the other ways that we can use.
So like we talked about when we explained our mathematical principle, mainly the two main parts are decontextualizing the problem and then contextualizing it again. So with the example of the problem we did for the K through 6 students about trying to take kids on a field trip and how many cars are needed, the students decontextualized the problem in the standard algorithm method, the box method, and the skip counting method when they reduced the amount of students just to the number 16, and when they used the number 6 to represent the amount that each car can hold. So in each of these methods, they basically just changed those that information into numbers and then manipulated it that way. Whereas in the circle method, they made dots to represent the amount of students that they had, and then they used circles to represent the cars that they were bringing. So that's how the students decontextualize the problem. And then after that, once they've gotten their answer, they have to contextualize it again. So for the standard algorithm in the box method, they realize that they have a remainder. So when the students go back to the real world and think, what is this answer telling me? They know that they need 3 cars instead of just 2, because you can't bring like 0.66 of a car or 2/3 of a car. They're going to need 3 total cars to take these students there. And then with the skip counting method, they realize they're going to need 3, and then they think back, okay, well I need 3, like what does that 3 represent? And then they remember that that 3 represented 3 cars that they're going to need for this field trip. So thank you guys for watching our video. Again, our principle or our mathematical practice was reason abstractly and quantitatively.
So if you guys have any other questions or just want to look more into what this standard means and how to apply it to your classroom, we have some resources. The Common Core website, Scholastic, other teachers. So if you want to look at those, we have those on our PowerPoint. Thank you for watching and see you later.